today we'll just quickly, I'll introduce green buildings, talk a little bit about green buildings and what's happening with green buildings here in the Emirates. So first we'll talk about the green buildings in the Emirates. We'll talk a little bit about embodied energy and the life cycle analysis. And then we'll talk about some passive energy conservation measures. So generally worldwide, buildings consume between 25 and 40% of the energy. They consume between 25 and 40% of the energy, and they generate about 30 to 40% of the solid waste, and as well the greenhouse gas emissions. The manufacturing would further add 10%, or they consume 10% of the energy. So generally you could say that buildings, or the construction of buildings around the world, they consume about 50% of the energy production. And of course this data is this is general worldwide data, but even in specific countries like the US or Canada, the numbers are very close to these numbers. So the solution of the industry, the AEC industry has come up with, is to make green buildings. Green buildings or high-performance buildings, they use interchangeably, but green buildings are generally the energy-efficient ones, and high-performance buildings are energy-efficient buildings with other parameters, superior parameters like safety and durability and so on. So green buildings, we have a lot of buildings that we call green buildings. But what exactly are they? So we call a lot of things green buildings, a lot of them. Some of them, they have used a reduction of materials or embodied energy. Some of them have a reduction in greenhouse gas emissions that they've achieved during the construction process. Some of them conserve water and energy during the operation process. And some of them just have a better indoor environment, and they can be tagged as green buildings as well. Generally, there are two ways that we make buildings green: through active systems or through passive systems. The active systems are any lighting or HVAC, or the systems that actively consume energy. The passive systems are systems like the building envelope or the orientation of the building, that if we change it, it will reduce the load on the active systems that would then consume the energy. So a general study that has been done shows that green buildings will consume about 14% lower cost, will run at 14% lower cost, and that's a very general number. It can go up to 30%, 40% sometimes. And this study is for the US, where it showed that there's an 11% increase in value, in market value for green buildings. The potential for green buildings, well, there's a lot of potential. The market's is growing and is very, it's not mature yet. So in the US, for example, it's estimated that 60% of houses are over 30 years old. There's a lot of scope of work, for this. In the UAE especially, there are 27% of buildings in Dubai that have not confirmed to any thermal insulation laws, that haven't confirmed to green building laws as of yet. In Sharjah, about 12.8%, and these numbers are conservative. The UAE is very ambitious, and it really it has a vision for energy efficiency in the region. So, for example, all these strategies have been done. The UAE Energy Strategy, for example, aims to increase energy efficiency of buildings by 40% by 2050. The environment vision, Abu Dhabi's environment vision, very bravely, they took the first step in acknowledging the problem, and they said that our buildings consume 10% more electricity than the average worldwide building. Of course, there are a lot of strategies that the UAE set in place. The UAE set in place to move in this line, and they've moved forward with it as well. So they established the Etihad Energy Services Company, for example, about 5 years ago or something, 4 years ago. And they were able to save, just in 2016, they were able to retrofit 2,000 buildings, saving 54 gigawatt hours of energy. So the life cycle analysis is basically, you have to analyze the entire building from the time the construction materials are being produced to the time the building is being disposed. And we can see there are a lot of analysis that have been done that shows that, okay, you can implement certain measures, you can change certain building materials, you can bring in new systems, and that will give you certain efficiency measures. You'll reduce energy by 5%, 10%. But if you do the holistic approach, if you do the entire analysis, and you say, okay, how much did it take, how much energy did it consume to create those building materials in the first place? Some buildings, they're very difficult to remove at the end of their life cycle, and it takes a lot of energy then to remove them. So if you do the entire life cycle analysis from construction material to the decommissioning of the building, you will find that you don't necessarily save energy or carbon emissions. Also, we have now the trend of materials is moving towards energy-intensive materials because we want high-performance materials. To get high-performance materials, they don't just come for free, so they consume a lot of energy. And at the same time, with these high-performance materials, they enable larger structures, taller buildings, and so high-energy materials plus taller buildings, you're really hovering around offsetting your benefits. There are other issues as well that would come up when you're looking at the long run, in the long picture. One of them is called the Jevons paradox. That is, when you increase the consumption efficiency, the price of energy goes down because there is less demand now. So that could affect probably a lot of countries in the world. In the UAE, it's not very applicable, although it is on a micro scale, since people now they get lower bills, so they're more encouraged to get more appliances and so on. But it's really negligible. Similarly, there's another paradox that we can look at, is that energy efficiency strategies, another thing that we can look at is the energy efficiency strategies can drive the price of the energy down. But again, that's not very applicable to the UAE because electricity and energy in general is heavily subsidized. Of course, there are various tools for looking into whole life cycle analysis and analyzing it. Generally in the building, the operational stage is the most energy consuming one. It consumes about 50% of the entire energy of the building, and that's especially in the HVAC system. In the UAE, the cooling load consumes about 70% of the electricity. So if we can solve problems with the cooling, there's a lot of potential there for energy conservation. We'll talk about some passive energy conservation measures like the orientation and energy modeling, as well as the envelope. So one study showed that just by changing the orientation of the building, I think it was 16 degrees, just by changing the orientation of the building, you can save up to 17,000 kilowatt hours of energy. It might not sound like a lot over the life cycle of the building, but you're getting it for free just by changing how the building, the direction the building points to. A study that was done here in the Emirates showed up to 55% energy savings, just again, orienting the building and reducing the size of the windows. The windows are very, very important when it comes to the design of the building, especially here in the UAE because we want glazing, we want glass everywhere. But glass is the most destructive thing in energy conservation. It's like having a hole in the wall, really. Energy modeling has now become mandatory. It's become part of the BIM process. It's in the sustainability 6D BIM, and in Istidama, it's going to come soon. The operational stage certification in Abu Dhabi. That's going to come pretty soon, and it's going to become mandatory law for it. So, again, staying with BIM and energy modeling, there are about 417 modeling softwares. currently stated on the Department of Energy, US Department of Energy's website, and there are more of them. The main challenge with energy modeling, it's very beneficial to tell you beforehand what measures could improve your efficiency of the building. But the main problem with energy modeling is the interoperability. Basically, if you use multiple software, one software for design, and then you move the model from the design software into the structural software, and then to the sustainability software, to the energy analysis software, you tend to lose a lot of important data. So this interoperability, it's a major challenge, and one needs to be very careful in choosing the correct software and the correct transfer mechanism. Generally, the disadvantages of energy modeling, and why people don't do it very often in the industry, is that it's very difficult to assume the data that needs to be assumed at the beginning when you don't have all the data. And it takes a very steep learning curve for the engineers. Regarding the building envelope, we see here that by just changing the insulation, by adding 1 inch of insulation, and by changing the glass of the building, the windows, to a double pane glass, we can achieve up to 30% or even 40% of energy reductions. Over here as well, we see that changing the walls and different combinations of walls and doors and windows, we get up to 30% energy reduction as well. You see, the interesting thing in this slide is if you just change the set temperature, the temperature you set your air conditioning at, if you change it by just 2-3 degrees, you get actually the most energy savings out of all the measures. Another thing is the thermal bridges in buildings. Usually the construction method that's done over here in the Emirates is we have an RC frame, a reinforced concrete frame, and then we have insulated bricks that go between this frame. So the RC frame forms a thermal bridge. It's not insulated, it forms a thermal bridge. And again, that's like having a hole in your insulation, and it drains all the energy through that hole. So this study again shows that you can achieve, again, up to 30% change by adding 160 millimeter full, 160 millimeter of insulation on the entire perimeter of the building, covering up the thermal bridges. If you just cover the thermal bridge itself without adding the insulation layer to everything, you get about a 20% increase in energy efficiency. Finally, thermal cameras. You can use thermal imaging to detect certain issues with the operation of the building. This here shows that how can we design the building to use thermal capacity of materials so that we can at least offset the energy demand to change it from peak hour to off-peak hour. So as you can see here, the dark side is the cooler side, and the bright side is the hot side, and there's a difference of there of 6 hours. So basically, thermal capacity of materials, if we use certain materials with high thermal capacity, the materials will absorb the solar radiation, but it won't send it directly inside into the interior of the building. So there's a delay, and that delay would allow to reduce the energy demand during peak hours and shift it towards off-peak hours. We can also use thermal cameras, and we use them in the industry to detect insulation, if there's a missing insulation anywhere, to detect thermal bridges within the wall, as you can see in the bottom image over there, and to detect air leakages through doors and through the envelope in general. Thank you very much.
Okay.